Have you ever wondered when you press a key on a keyboard, how does the computer know exactly what you have pressed? Or when you withdraw money from an ATM at midnight, how does that machine talk to the bank servers? The answer is quite simple, a software. To be specific, operating system. In today's session, we will cover one of the most important topics for your PSC and banking exams and for understanding how the digital world works. By the end, you will know what an operating system or in short OS is, why it's needed, its key functions, different types, and how it powers banking systems. So without any further ado, let's dive in. साथीहरू नमस्ते। म आज फेरि पनि एउटा अर्को टपिक लिएर तपाईहरुको सामु उपस्थित भइसकेको छु र आजको हाम्रो विषय रहेको छ अपरेटिङ सिस्टम। So let's start with a very basic and simple definition that says an operating system, or in short OS, is a software that manages computer hardware and software resources. Yes, I know this is not only the hardware and software management, but for the time being, let's assume. And now let's make that more precise. So first, focus on the software part. So basically in computer world, software is a combination of intangible part of an application that is designed for a specific purpose. That software is always categorized in three types. One, an application software. Second is system software. And third is utility software. So here, system software are those softwares which are designed to comprise the system, or we can say it is the part of the system. Second is an application software. Application software are those softwares that are designed to accomplish a certain task or to achieve a certain objective. Things like a word processor like Microsoft Word in Excel or similar one. Similarly, utility software is a software that is neither the part of the system nor the part of the application software, but the utility software would help to do the work or the task better and in efficient way. So those software are called the utility software. So here we are talking about the operating system, and operating system falls under the system software. So what we can say now is an operating system is a system software that acts as an interface between the user and the computer hardware. It manages all the resources, provides services for application programs, and controls overall operation of a computer. So key exam term: OS is the first software loaded onto the memory when computer is turned on. This process is called booting. Remember that word. It often appears on the exam questions. Now, why exactly do we need an operating system? I have a story to make the OS unforgettable about that. Imagine a grand royal palace in an ancient time. The king wants to send an important message, get food from the kitchen, and light the torches in the hall, all at the same time. But king cannot walk to the kitchen himself. He sits on the throne and gave order. There is one person who manages everything: the prime minister. He receives the king's order, knows which servant handles which task, send the right servant to the kitchen and another to light the torches and ensure the messages reaches its destination all at once. He keeps everyone from bumping into each other, manages the palace budget or resources, and ensure no unauthorized person enters. Here, what we can resemble is the king is you, or the computer user, and the prime minister itself is the operating system. The servants could be the device driver or the system services, and similarly the palace is the computer hardware. So without the prime minister, the king cannot function. The king doesn't know where the kitchen is and how torches work. He just know what he wants. Prime Minister handles all the complexities. When you click print, you are the king giving an order. The OS or the Prime Minister finds the write solvent or the printer driver and sends the document to it and manages the queue if other documents are waiting. So you never need to know how the printer works. So in similar way, operating system also do the heavy lifting for the computer user or the application software. So what they want or what they do would be way more tedious if there would be no operating system. So the common tasks like how the computer hardware could do the job or which kind of commands to be provided for the computer hardware are solved by the operating systems. As we all know, computer only knows in the digital form or binary bits, that is either 0 or 1. So in order to get a function from a hardware, we also need to command that hardware only in the binary bit. But we don't know the binary bits. The user don't know the binary bits. So what user sends or what user tries to execute, they give commands in the English or in higher level languages, and operating system convert them into the binary bits and binary commands. That's where the necessity of operating system comes into play. So the operating system is kind of the interface between the user and the hardware. Usually talking about the structure of the operating system, generally an operating system has three main components. Let me explain each one. So the first part of an operating system or first component of an operating system is a kernel. Kernel is the heart of the OS, first loaded during booting. So this is the component where the actual hardwares are controlled from, or we can say the kernel directly controls the hardware like CPU, memory, I/O. So think of it as an engine for a car. Invisible, but nothing works without it. Anything or any command you have given to the computer is directly executed by the kernel on a hardware. Second component of an OS is user interface or the UI in short. So UI is the component or abbreviated form of graphical user interface. Graphical user interface or GUI is the component where the user gets its terminal or from where the user gets input or output into or from the computer. So these are the kind of terminals where the user involved using the computer. Normally these are the terminal or any UI application like desktop or something like that. Third component of operating system is the system services or the utilities like file manager, task manager, device manager. Usually an operating system exposes these services to be consumed by the application software or the other utility software to execute something on the kernel of the computer system. So kernel, user interface and system services or utilities are the mainly three components of the operating system. Among them, the kernel is the most essential component. There are also the types of kernel like monolithic and microkernel, but this is the topic for the another video. If you like to know more about this, please do comment. I will make another video elaborating on this topic. So the next part is what are the functions. Usually talking about the functions of operating system, we mostly talk about 5 functions of an operating system. Among them, first is the process management, second is memory management, third is file management, fourth is device management, and fifth is security management. So let's talk one by one each. So talking about the process management, it is the function of an OS to manage all the process of a computer running at a time, or how to run the processes in a computer. So OS manages which processor gets the CPU and for how long the CPU will be serving that process. For now, what we can understand is computer not only runs one process, but for nowadays computers, it can handle many more processes all at once. Even with a single core of a CPU, a computer can handle multiple processes with something called time sharing. What is also the task of an OS is to schedule the processor to each task efficiently so that processor can be switched to every task that appears simultaneously, so that it is felt like computer is processing multiple processes at the same time with a single core. However, the reality is computer is only processing one process at a time, but changing each process or changing the CPU for each process at a very fast rate so that user perceives that the processor is processing multiple processes at the same time. That's why when we see the specs or when we validate the specs of a computer, it says a very few number of processor or very few number of cores for the processor. However, if we inspect the computer processes in a real computer, we get way more processes is processing with that limited amount of CPU processor cores. Second function of an OS is a memory management. So OS always controls how RAM is divided between the programs. As we all know, we can run multiple programs at the same time using the computer, but how much memory will be allocated to which program is decided by the OS. There are few concepts like paging, segmentation, virtual memory regarding this. So talking a little bit about those, like virtual memory is the space when the primary memory or the RAM usually gets full or occupied totally, then the OS reserves an extra amount of memory from the hard disk. So that memory is not a primary memory. However, for that specific moment or for that specific time, they can be used as a primary memory. That's why those are called the virtual memory. Next is the file management. So organization of the file is yet another function for an operating system. So as we all know, there are lots of file systems. For as example, as we have used with the removable disk, we have FAT32. Similarly, if we have operating in a Windows operating system, there is something called NTFS. Similarly, in Linux, we have heard about the ext4, and in the Apple or Mac OS, there is an APFS. APFS is an Apple file system. So these are all the file systems regarding to their own specific operating systems. These are the kind of protocol for the management of the file. So operating systems always defines how these files are gonna be saved in a storage or a hard disk. That is one reason if we have saved one file in one operating system, if the operating system doesn't support that file system, then it could not read that file system. So what is happening is, if we have formatted a disk with a APFS and if we plug that disk into a Linux machine, it will not read unless or until we provide that Linux with a software that can recognize the APFS. So what it concludes? Concludes that every operating system has its own file system management, and they handles the permissions, who can access the file, how to read the file, what kind of data or what structure the file will be saved in a disk. So these are all the parts of the file management as a function of an OS. Next function of an OS is a device management. OS not only manages the process, memory and file, but also manages the device connected to a computer through the operating system. So OS manages these devices via the special programs or special softwares that are called device drivers. These are the kind of translator between the operating system and the device hardware, and usually these device drivers are built or provided by the hardware manufacturer. So they know how the device works and they provide these device drivers with them so that an OS can communicate with the hardware and could perform the tasks that are executed in an application or an operating system requirement. So the device management is also the function of an operating system. And the final function of an operating system is a security management. So remember, we can log in into the computer system, or we can assign the permission to a file or a data in a computer. We also have the firewall in a computer system. We do have a logs in our computer operating system. So All these things comes under the security management as a function of an OS. And more specifically, if we are thinking in a banking systems, this is the most important function of an OS. So now let's talk about the types of an operating system. These could appear directly in an exam, especially for PSC and banking exams. Usually, we can say there are the four major types of an operating systems. First is batch OS, second is time sharing OS, third is distributed OS, and fourth is the real time operating system or RTOS. So let's talk each one in details. First of all, batch OS. Batch OS were the initial stage operating system where users are required to collect the tasks or jobs for the computer, and they were collected and provided through the punched cards in early stages of the computer development, and they were submitted through an operator, and operators fed them into the computer and wait for the processing. So in batch OS, jobs are collected, grouped, and processes without user interactions. And as I have said, these are the early stages computer operating systems. For example, early IBM mainframes, payroll systems. So there will be no real-time interactions and jobs were queued in batches. So as they are collected and grouped and then fed through the punched cards. Second is the time sharing OS. Most of the computers we use today falls under these categories. In this operating systems, CPU time is divided into time slices called quanta. Each user gets a rotation, creating an illusion of a dedicated CPU. Examples of such systems are Unix, Linux, Windows, Mac OS, and most common type today. So as name suggests, the whole computer is divided or shared over the time. In this kind of operating systems, multiple users processes or initiates a process into a single processor, and each process will be allocated the CPU or processing power for a certain amount of time. That allocation changes at a higher speed or at a higher rate so that the user perceives to have a dedicated processing capability. Next is the distributed OS. As compared to the time-sharing operating systems, distributed operating systems are also shared, but besides the time, they share the task. In distributed operating systems, there are multiple computers connected through the networking and known as nodes. Among them, one computer is assigned as a master and other are considered to be a slave node. And while processing or computing with those kinds of operating systems, the master nodes always receives the job or task and distribute them among the slave nodes, where each slave gets its tasks done and report back to the master node, and then master node will report that to the user. Example of such computer systems or computer operating systems are like Hadoop, Google servers, infrastructure, cloud computing, and so on. Lastly, the final operating system is real-time operating systems. Among the all operating systems above, these are the most suitable operating system for the time-critical applications like airbags, missiles, medical equipments, and similar. These are very time critical and applicable where the response time is the prime consideration. The real-time operating systems are those where process the data within a strictly defined time. So let's assume, for example, there is a airbag in a vehicle that takes a few time before inflating, so this could kill the passenger. That's why their time is very critical. Among those, there is two kinds of RTOS. One is hard, another is soft. If the time is very strict, then it is called the hard RTOS. For example, as I have said, airbags, missiles, and medical devices. But for some systems, it may have some flexibility, such as in video streaming or audio systems, like one used in ATM machines. Let's now connect all those with the real world examples. So as we all know, we have a very well known example of the operating system that is widely used in today's world called Windows. So Windows is an operating system built by Microsoft, and it is time sharing, multitasking, multi-user OS with GUI. It uses NTFS file system and is used in most of the offices, personal PCs and banking workstations. Second example is the Linux. Linux is open source, for example Ubuntu, Red Hat, CentOS, Fedora, etc. It is also time sharing, multitasking, multi-user. It uses ext4 file systems and preferred in server applications and research purposes. It is also known for security, stability and flexibility. Third one is macOS, built by an Apple. It is built on Unix. It is also time sharing, multitasking. It uses Apple its own file system called APFS and used for creative industries mostly. So as we have given example, all the Windows, Linux and Mac OS uses time sharing and multitasking. Beyond that, also there are various operating systems that it is not possible to enlist all of them here. So now let's focus those examples in the banking sector. We have one of the operating system in banking sector that is used for the ATM systems. Usually ATM systems run over an embedded OS or specially customized operating system of any of the variant like Windows, embedded or Linux, with the extra capability to manage card readers, cash dispensers, receipt printers and network functionalities. This operating system is also the time critical operating system. So this is also the mix of some kind of RTOS. Another operating system used for the transaction processing. So thousands of transactions per second must be processed reliably, governed by ACID principles. ACID principles stands for atomicity, consistency, isolation and durability. So OS and database combinedly enforces this together. Another is database systems. So OS manages hardware resources for massive banking databases, memory allocations, disk IO, simultaneous queries. Most servers run Linux or Unix for stability. Fourth, security, user authentication, password plus smart card, file permissions, so that every user has its own authority and authorizations. OS level firewalls, audit logs for compliance. That's why Linux preferred for its robust permission model. So finally, few things to summarize from this video is: first, OS is a system software and interface between user and hardware. Then kernel is loaded first, starting the computer. That is known as booting. Without OS, users cannot communicate with hardware. So the model is user communicates with OS and OS communicates with the hardware. Generally, there are three components of an operating system. First is kernel that controls the hardware directly. Second is user interface, from where the user interacts with the computer. And third is system services or utility services. Fourth thing to remember is 5 function of computer. First is process management, second is memory management, third is file management, fourth is device management, and fifth is security management. Fifth point to remember is the types of OS. First is batch OS, second is time OS, third is distributed OS, and fourth is RTOS or real-time operating system. Sixth point to remember is Windows, Linux and Mac. All are time-sharing, multitasking operating systems, where Windows are preferred for the workstation purposes or personal PC purposes, Linux is preferred for the server purposes, and Mac OS is generally critical or luxurious, creative kind of operating systems. And the last point to summarize is: in banking, OS powers ATMs with real-time operating systems, handles the transaction properties with ACID principles, and handles database services and security. So let's see about some of the questions regarding the operating system. I have a bunch of multiple choice questions here where I will explain and then show you the answer. So the first question says, which part of the operating system directly interacts with the hardware? Options are cell, kernel, compiler, and device driver. So what we know is cell is a user application or the GUI application where it accepts the input from the user and sends that command to the kernel. So as we know, cell doesn't interact with the hardware directly. Option B is the kernel. As we have studied, kernel is the heart of an operating system which directly controls the hardware. So option B must be the answer of this question. However, let's see the other options. So compiler C, option C is a compiler, and compiler is a piece of software that converts high level code into a machine level executables. So compiler is also not the option of this question, and option D is the device driver. So device driver also interacts with the hardware, but device driver falls under the services or system services category. That's why the more appropriate answer for this question is kernel. The kernel is the core component of the OS that directly manages hardware resources including CPU, memory, and I/O devices. It runs in privileged mode and is the first program loaded during the booting. Next question is which type of OS is most suitable for an ATM machine? First option is batch OS. As we know, we have discussed, this is the early stage operating systems where there is no user interaction, and we know in ATM we need that. So the option A is not an appropriate answer. Option 2 is distributed OS. So the distributed OS works in a cluster with a multiple nodes, and in ATM it is not the scenario. So option B is also not an answer. Option C is real-time operating systems. Yes, in ATM we do need the time criticalness, so the real-time operating system is the correct answer for this question, and option D is time sharing OS, which is not the case for an ATM machine. So the answer is option C, real-time operating systems. ATM machines require immediate response to user input. Real-time OS guarantees response within a defined time frame, making it a deal for the ATMs and other time-critical banking hardware. Similarly, third question is virtual memory in an operating system refers to option A, a memory in a CPU register, which is not the virtual memory actually. It is called the register itself, so this is not an option. Option B is extra RAM sticks added. This is also not the case. Option C is hard disk used as a RAM extension. So this is known as the virtual memory. When RAM got full or it's about to full, operating systems allocate some of its hard disk space to be used as a RAM, and that is called the virtual memory. So option C is the correct answer. And for option D, ROM used for booting is not called the primary memory, or it's not for the RAM purposes, so it's not the answer. Answer is option C, hard disk used as a RAM extension. So virtual memory allows the OS to use secondary storage, hard disk, as an extension of a RAM, enabling larger programs to run than physical RAM would allow alone. Then question number 4 comes, which file system is used by default in Linux operating system? Option A is NTFS. As we know, NTFS is used in Windows operating system, so this is not an option. Option B is FAT32, which is also the file system for usually removable devices or removable disks like pen drive and all this, so this is not a correct option. Option C is APFS, that is Apple file system, and which is also not used in the Linux operating system. That's why option D is ext4, that is used in a Linux operating system. So the correct answer is option D, ext4. Linux uses the ext4 or fourth extended file system. Next question is, the process of loading an operating system into memory when a computer is switched on is called option A, compilation. As we know, compilation is the process to convert high level code into executable binary in a computer system. That's why it is not the correct option. Option B is booting. Yes, the process of loading loading an operating system into a memory when computer is switched on is called booting. Option C is rendering, which is related to the graphical process that creates something on a screen for the display purposes. So this is not an option. And option D, caching, is the process of saving something for the future uses. That's why it is also not the correct option. Correct option is booting. Booting is the process of starting the computer and loading the OS into RAM from secondary storage. The initial boot instructions are stored in ROM as the BIOS or UEFI firmware.